welcome back. In today's video, we are going to see allocation method of memory. We have to allocate the memory to every process. So how the allocation happen? Before going to that thing, we have to know two important concept. That is address translation and base and bound technique. So what is address translation? Suppose there is a process and this need physical memory. Okay, this is a physical memory. This need this physical memory. Okay, so in previous video I tell you that directly physical memory is not allowed. We have to give them the virtual memory. Suppose the virtual memory give is to 16 KB. Okay, this 16 KB is mapped to the physical memory like this, 32 to 48. Okay, and the some space also take by OS. Okay, OS. So this mapping is called, the mapping of virtual memory to the physical memory is called address translation. Address translation. Because we cannot map directly to the physical memory. Why we cannot do it? We learned about this in the previous video. To give the abstraction, isolation or protection to each and every process, we have to do the virtual to physical memory mapping, and this thing happen with the help of a technique that is called base and bound technique. Base and bound technique. What is this technique? Okay, in this technique there are two resistors, one for base and other for bound. So if there is a virtual memory and it's mapped to a physical memory, okay, like this, here 32, here 48, it is 0 to 16. So the base of the physical memory, from where this process starts, is called the base. Here it is 32. Okay, and this base is helped to map the each and everything. How? Suppose there is a one thing at 15 KB here. Okay, suppose one thing is at 1 KB here. So how will you map it here? You map it here with the help of physical memory is equal to base plus virtual. So if anything is at 1 KB, so base is 32 plus 1, 33. It will be mapped at 33. Similarly, if anything is 15 KB, so it is 32 plus 15, 47 KB. This is how map. Then what is the use of bound? Bound is basically used for protection. How? Bound tell you that the maximum size of virtual memory. Here it is 16. So it is 16. So if any process want a physical memory beyond this bound, CPU give you exception. So exception. So bound is help for protection and base is help to mapping. These are the two concepts. So how this mapping happen? There are basically lots of methods. We will discuss two methods. Okay, one is fixed, other is dynamic method. So in fixed method, what will happen? This is a physical memory. OS initially divide this memory into the fixed size. Suppose this is a fixed size. Okay, so these are 6 MB block. Okay, now suppose a process come and it need 3 MB of space. This is allotted to them. Another process come 2 MB. This is allotted this next. Another process come 6 MB. This block is allotted to them. So what will happen? This whole block is allotted to this 6 MB to a process which need only 3 MB. So this 3 MB is wasted. 3 MB is wasted, and this wastage is called internal fragmentation. This wastage is called internal fragmentation. Okay. Another thing, here the OS divide the whole memory into 4 different parts, 4 different fixed parts. So the multi-programming, how many programs simultaneously can run, is one fixed by OS initially. So multi-programming is fixed here. Now another problem is here. If suppose any program come, then need 10 MB of memory. How it is allotted? Not allotted, because the OS divide it into a 6 MB. So not greater than 6 MB is allotted to any process. Even if there are 2 fixed slots available, still it is not allotted, because it is already partitioned by the OS. So two partition memory can't be allotted. So that's the reason if any big process come greater than the memory requirement of the internal uh, partition, then it is not allotted, and this is called external fragmentation. This is called external fragmentation. Okay. So to achieve a new way, to find out a new technique where these all the problem does not happen, we come with a new technique that is called dynamic partition. Dynamic partition. So is this solve all our problem? Let's see. Suppose this is OS. In dynamic partition, if any process come requirement of 2 MB, it is allotted to them 2 MB. Okay. Other process come require 8 MB, it is allotted to them. Okay. Other process come, it require 2 MB, it is allotted to them. Here there will be a no wastage of space. So internal fragmentation is not present in dynamic. Multi-programming here is not fixed, even increased, because there will be a no wastage, so multi-programming must be increased. But is external fragmentation also not present? Let's see it. Suppose another process come which require 3 MB of space. Okay. Now suppose here all the space is full, so this process is not allotted to them. Now suppose this and this space is now free, and 8 MB space is already allotted and the process is continuously running. So now is the 3 MB is allotted to this? No. Why? Because we need continuous space, not this type of space, not discrete space. We need continuous space. So external fragmentation is also present here. Even space is present. Even space is present. External fragmentation is present here, because that cannot be allotted, because the space is not present continuously. So in dynamic also space problem is helped. So these are some difficulties which we face in the fixed and dynamic programming. Once again we revise it. We start with a memory management, address translation. The mapping is called address translation. This is happened with the help of bound and base technique. Then we see the fixed partition, where the internal fragmentation, fixed multi-programming, and external fragmentation problem is happen. Then we see the dynamic, where internal fragmentation problem is not present, multi-programming get increased, but external fragmentation is present, because even the space is present but the space is not present at continuous level, so the memory is not given to process. So these are the problem of dynamic programming. We in the next video see how we can remove this problem in the upcoming video. Till then, goodbye.